As a business that does a lot of manufacturing, our CNC machine has quickly become the most important tool in our shop. And although these are great, they're also really expensive. So today, we're going to show you how we built one. .3D printers started getting cheap while we were in college. During a holiday sale, we finally got one and started to print. This was the first time we could prototype quickly and easily. It didn't take long for us to discover the limitations of plastic. To take us further, we would need to have some sort of traditional machining capability.
During a project, we were trying to make plates that had precisely located holes. They needed to be made of aluminum, and making them required time, equipment, and tools that we didn't have. We thought instead of getting a workshop's worth of stuff, we could get a cheap desktop CNC machine that would allow us to make the parts ourselves. The first place we started to look for a machine was on OpenBuilds. Their kits were a little too expensive for us, and we thought we could definitely find a way to do it cheaper. Instead, we bought a few parts from OpenBuilds and then scoured the internet for the rest of what we needed. As you would expect, that process not only took weeks to complete, but cost far more than the original OpenBuilds kit. Planning the build, we want to be able to cut up to 1/4 inch thick aluminum plate, even if it needed to be cut slowly. We also wanted to be able to machine MDF and tooling foam for mold making and other composite layouts. We thought this would definitely be achievable.
The biggest problem we ran into was that we didn't have a shop or CNC machine cutting things square or accurately. Instead, Isaac was cutting all the aluminum extrusion and making the plates by hand, which meant that they were all not perfect. Before starting this build, both of us didn't really know much about rigidity as it relates to a CNC machine. We had to learn the difference between V-slot and linear rails and how to make things rigid as we went.
The machine is up and running, and we're cutting MDF in my living room. This is accompanied by dust collection with a Harbor Freight shop vac. Oh! In order to avoid being evicted by my roommate, who had very kindly allowed this process to happen so far, we moved the machine outside for the time being. Clearly, we had no idea what we were doing. There were 0 safety measures in place, no dust collection, and we were cutting at a snail's pace. It's all pretty questionable, and there's room for improvement. We're making a lot of mistakes, but we're learning a ton during the process.
One of the things we learned was that CNCs experience cutting forces, so there's deflection in all the components. See how the Z-axis is bending here? This means that our optimistically precise holes are not getting put in the right place. It was clear the upgrades to this machine would need to be related to its strength. Isaac upgraded the frame with some steel components.
First iteration, and it ran pretty well. I was getting a lot of deflection and having some significant issues on that front, which is why we're upgrading. But it's important to remember that this thing was designed pretty much strictly with budget in mind. So for, under $1,000 to have a CNC with 36 by 36 workspace and relatively rigid was a win in my book. And now we've got some beefier components and rails that should take us to the next level, hopefully, in terms of what it's capable of. I TIG welded a lot of the parts together. The aluminum extrusion came anodized, and I had no real idea how to TIG weld at this point. Shockingly, that did not go well. It also ended up being a great way to achieve a really warped and not flat surface. Perfect.
As we slowly made the frame more rigid, we could cut faster, more accurately, and process harder materials. Another issue was that we were using a router with a minimum speed of about 16,000 RPM. This means that we have to cut the material quickly or it will overheat. In the end, it would have been much easier to just buy a machine, but if we did that, we wouldn't be able to make mistakes and feel like idiots the whole time. It built all the parts for our large dual extrusion FDM printer, turned a lot of MDF and tooling foam into dust, not to mention how much it taught us about machine design. At this point, we felt confident knowing what upgrades made it better and what had not moved the bar. With each updated version, we were able to make parts using the machine, so everything got 50% better each time.
Turns out it's a whole lot easier to build a CNC machine once you have a CNC to make parts for it.
Although this machine was technically capable of processing what we would need for our business, we didn't really trust it to, for example, do a 12-hour production run for our customer. We decided to take everything we had learned so far and build a new machine from the ground up.
first thing to consider was the frame. We got an amazing deal on a really good gantry, spindle, and VFD, so that was all taken care of. Those all came from a 25-year-old used machine that had been thrown into a dumpster. From there, we wanted as large of a workspace as possible while trying to still make use of those parts. This means we would still need to build a frame, table, Y-axis, and all the electronics. In some ways, it was more difficult than starting from scratch because although we had nice parts, they now needed to fit into whatever else we built.
There were a few options for how to mount the machine. We considered a large aluminum extrusion build, but we couldn't justify the cost of that. We ended up designing and building an extremely solid wooden table. The CNC then gets attached to the top MDF panel. The frame and Y-axis were designed simultaneously. They're made of aluminum and support the linear guides and rack for the Y-axis motion. The alignment and dimensions of these parts are important. If we were off parallel by half a degree while putting it together, the linear guides would end up binding at the end of the table. For our controller, we went with a Motiv G3. This would let us have an all-in-one system that we didn't have to worry about or spend months programming. With that chosen, we started to work on all the microelectronics. Every part needed its own considerations while designing the wiring harness. This harness needs to control everything: motors, switches, sensors, thermal protection, emergency shutoff, and the spindle. This was, to say the least, intimidating.
We wanted to take a different approach to wiring this machine. Unlike previous versions, we wanted to be able to run for long periods of time unattended. In order to make this happen, it had to have thermal protection, safety circuits, high-quality connectors, and be wired very differently than the last one. As we were putting all the electronics together, I was having a lot of problems with the VFD and its communication with the Motiv and spindle. It's me touching the case.
Yeah. And this is all grounded like back to the wall. That's pretty funky.
I spent about a week pouring through old manuals and testimonials by people who had just discovered the internet back in 2010 telling me how to wire the VFD correctly. At the end of the day, I lost that battle. We ended up having to buy a new VFD, but now the machine runs perfectly.
We'll be making a few more videos on the details of this CNC build soon. If there's something specific you're interested in, please comment and let us know. We'll make sure to cover it. We now have our website up and running and full of products for sale. If you feel like supporting what we do while also getting something really cool in return, please check it out. It's the first link in the description. We have a few more YouTube projects on the horizon. Projects like our laser cutter, 3D scanning for motorsports, and other engineering R&D. If that sounds interesting, consider subscribing.